Hi everyone, welcome back to a new video, and from this video we are going to dive into some new topics. In the next few videos I'm going to cover some lead code problems which are going to require us to deal with some intervals, and starting with that, today we are going to solve two problems. The first problem is meeting rooms 1 and the second problem is meeting rooms 2. So let's have a look at these two problems. The first problem is quite straightforward, and here we are given an array of meeting times and we have to determine if a person can attend all the meetings. And the second question is we have to return the minimum number of rooms required to attend all the meetings. So for the first problem, we are given an array of meeting times, and this array can be represented like this. So we are given a 2D array, and the first element is this, and second element is 5, 10, and third element is 15, 20. So as you can see, it's a 2D array, and the first element in this 2D array is of size 2, and second and third elements are also of size 2. So in this 2D array, the number of columns is going to be equal to 2, and there can be any number of rows, and the first column is the start time and the second column is the end time. So if I draw these values on a number line, so it would look something like this. So this is going to be 0, and 30 is going to be somewhere here, and then 5 would be somewhere here, and 10 would be here, and 15 would be somewhere here, and 20 would be here. And we have to determine if a person can attend all the meetings. As you can see from the diagram that this meeting is clashing with this meeting and this meeting is clashing with this one. So either we can attend this meeting or we can attend these two meetings. So we cannot attend all the three meetings, so we have to return false in this case. And if there is no overlap, for example, if there are two items, let's say 7, 10 and 2, 4, and this is a separate 2D array. So for this case, if we draw the times here, so 2, 4 and 7 would be here and 10 would be here. So as you can see, there is no overlap. So for this case, we have to return true. So this is quite straightforward, as we can compare a particular meeting time with all the other meeting times and determine if a particular meeting time is clashing with another meeting time. Then we can return false and we would be done. And at the end, when we have processed all the pairs, then we can simply return true. So if we are going to compare every meeting time with one another, it is going to take O of n square time. So the question to ask ourselves is, can we do better than O of n square? So the answer is yes, we can do this question in O of n log n. So let's see how we can do this in O of n log n. Let's say we are given this example. One thing by which we can improve our running time from O of n square to O of n log n is sorting these meeting times based on the start times of the meetings. So here, as you can see, the meeting with the lowest start time is this one, and then this one, and then this one, then this one, and then this one, and then this one. So let's sort these meetings and see what we get. So we will have 0, 10, and then 1, 2, then 4, 4, and then 5, 6, and then 7, 7, and then 20, 40. So let's try to draw this on number line. So this is going to be 0 and 10, and then 1, 2 be somewhere here, 1, 2, and then 4 will be somewhere here, then 5, 6, and then 7, and then 20 would be somewhere here. So now we will not have to compare a particular meeting time with every other meeting time. We can simply compare this first item with the second one. So basically we can simply compare adjacent meeting times, and if they are overlapping, then we can simply return false. And in the case when they are not overlapping, then we can simply move on to the second item and then compare this second item with the third item. And in case second, third are not overlapping, then we can move on to the third item and then compare this third item with the fourth item. And if we reach till the end of the array and we don't find any overlap, then we can simply return true. And in case any adjacent meeting times are overlapping, then we can simply return false. And this way we can improve the time complexity from O of n square to O of n log n. For the second problem, we have to determine the minimum number of meeting rooms that will be required to schedule all the meetings. In this example, we are given this array which has these 3 rows and we are given these 3 meeting times. So I have drawn these 3 meetings on the number line. So as you can see that these 2 meetings are clashing with this meeting. So when this first meeting is going on, we cannot schedule this second and third meeting as there is going to be a clash. So we can allocate a particular room to the first meeting and allocate a separate room to the second and third meetings as there is no clash between meeting 2 and meeting 3. So the minimum number of rooms required is going to be equal to 2. Let's say we have this example of the meeting times. So let's discuss the first approach. So the thing which is going to decide whether we are going to need a new room for a particular meeting is whether some existing room is already occupied by a previous meeting or not. If it is occupied by a previous meeting, then we are going to need a new room. In this example, the meetings are not sorted by start times, so we are going to need some sorting. So what we can do is let's create 2 different arrays. So the first array we can create is of start times and the second array is going to be of end times, and both of them are going to be sorted. So the first array items, they are going to look something like 0, 1, 4, 5 and 7 and then 20. And the end time array is going to look something like 2, 4, 6, 7, 10, 40. So we have these 2 arrays of start time and end times and these are sorted. So what we can do is we can use 2 pointers. So the first pointer is at the 0th index of start array and the second pointer is at 0th index of end array. So this value 0 is start time of some meeting and this value 2 is end time of some meeting. And it is not necessary that these are start and end times of the same meeting. These can be start time and end times of any meeting. The thing which we care about is the end time and whether we are going to need a new room or not. We are going to check if the value at index I is greater than or equal to the value at index j, which is false. So this means that we are going to need a new room and we are simply going to increment I. So I is going to be at value 1 now and j is going to be at same value. So again we are going to check if the value at index I is greater than or equal to value at index j. So 1 greater than or equal to 2, this is false. So again we are going to increment value of number of rooms and also increment the index I. So now I is going to point at value 4 and so far the number of rooms required is 2. So now we check again if 4 is greater than or equal to 2. So that is true. So now we increment both I and j. So now j is at 4 and I is at value 5. Now we again check 5 is greater than or equal to 4. So this is true. So now we simply increment I and j. So I will be at 7 and j will be at 6. Now again we are going to check 7 greater than or equal to 6. That is true. And now we increment both I and j. So j points to value 7 and I points to value 20. Now again 20 is greater than or equal to 7. That is true. Now we increment I and j is at value 10, and now I has crossed the bounds. So once I has crossed the bounds, we can simply return the number of rooms, and this is going to be the minimum number of rooms required, which is equal to 2. So using this approach, we can solve this problem in n log n time plus O of n iteration. So overall it's going to be n log n. For our second n log n approach, again we are going to need some sorting based on start time and end times. This time let's sort this array based on the start times. So after sorting this array based on start times, it is going to look something like this: 1 2 and then 4 4 and then 5 6 and then 7 7 and finally 20 40. So this is our array after sorting based on start times. And now for sorting based on end times, we can make use of a min heap. So initially we are going to start from index 0. This is going to be our current interval, and we can simply add this interval to our min heap 0, 10, and we can increment the number of rooms, and we can assign this first room to this meeting. And now we move on to our second meeting, and here we check if the start time of this meeting is greater than equal to the end time of the minimum interval in our min heap, which is 0, 10. So 1 is not greater than equal to 10. So what this means is we cannot use this particular room for this meeting. So what we can do is we can increment the number of rooms and add this interval 1, 2 to our min heap. Now in this case 1, 2 is going to be the minimum element in our min heap, and 0, 10 is going to be pushed downwards. And now we come to our next interval, which is 4, 4, and now we check if the start time is greater than equal to the end time of the minimum in our min heap. So that is true. Now what we do is we simply poll the minimum from our min heap and add this new interval to our min heap. So our min heap is going to look something like this: 4, 4 and then 0, 10. And also when we were at the interval 1, 2, our number of rooms got incremented. For this interval 4, 4, 4 is greater than equal to 2. So what this means, we can simply utilize this room for our current meeting. So that's why we simply pulled out the min element from our min heap and added the current interval to our min heap. So the next interval is 5, 6, and now we check if the start time is greater than equal to the end time of the minimum element, and that is true. So we simply pull out this one and add our new interval. Since we are maintaining the min heap based on end times, so that is why 5, 6 is going to be the minimum element in our min heap. And next interval is going to be 7, 7. So the start time is greater than equal to the end time. Now we do the same thing. We poll this one and add our new interval 7, 7. And next we come at 20, 40. So the start time of this one is greater than equal to the end time of this one. So again we poll this one and add 20, 40. And this is going to rearrange, and 0, 10 is going to be the minimum element and 20, 40 is going to be somewhere below. So now we have processed all of the meetings, and our min heap has 2 elements. So either we can simply return min heap dot size, and this is going to give us the minimum number of rooms required, or we can simply return this variable or return rooms, and this is also going to give us the minimum number of rooms required. So I highly encourage you to draw diagrams to understand this better. And now let's dive into the code implementation. So for the coding part, since both of these problems are LeetCode premium problems, so I have created some test cases. So here in my main function, I have created some test cases, and now we can implement both of these functions. So let's start by implementing the can attend meetings function. If we cannot attend all the meetings, then we have to return false, and if we can attend all the meetings, then we have to return true. So for this, we have to compare adjacent meetings. So in order to compare adjacent meetings, we need to sort our 2D array by start times. And initially we can add a check where intervals dot length, if it is 0, then we can simply return true. And moving on, we can now sort our array. So I can use arrays dot sort and then pass in intervals, and then I can define a comparator, and inside of this it will be integer array comparator, and then I can create my compare function, public int compare. So this could be int array I1 comma int array I2, and the first entry is going to be start time. So we can simply return I1 0 minus I2 0, and since we have to sort this in ascending order, that's why I1 comes first before I2. And we can import this one, add all missing imports. So yeah, that fixed the error. And moving forward, now we have to compare adjacent intervals. So initially what we can do is we can create a current variable and assign it the first value, which is at index 0. And now we can compare adjacent intervals. So I can start from index 1 and then go all the way till intervals length -1, then I plus plus, and inside of this, the interval at index I can define it as interval equal to intervals I, and now I can compare this interval variable with this current variable. So if these two intervals overlap, then we have to simply return false. So in order for them to overlap, the start time of interval should be less than end time of current. If this is the case, then we can simply return false, and if this is not true, then we can move on to the next interval and can set current equal to interval, and in the next iteration this interval variable will be assigned to the interval at index 2, and so on. And if we manage to iterate over the full for loop and reach here, then we can simply return true, as there is no overlap, and if any of the two intervals overlap, then we simply return false. I'm going to discuss the min heap coding solution for this problem, because that solution is slightly harder than the other n log n solution that we discussed in our algorithm walkthrough. So from our min heap algorithm discussion, we discussed that we need to sort our intervals array by start times. So I can simply copy and paste this one here. So this will give us the intervals array sorted by start times, and next we can create our min heap. So for that I can use priority queue, and it's going to be priority queue of integer array min heap new priority queue, and then we have to define our comparator. And inside of this we have to create our compare function. So public int compare int interval 1 integer array interval 2, and we can simply return interval 1 1 minus interval 2 1. So because this min heap is created based on the n times, that is why we are using index 1 here. Moving forward, we can create a variable to store minimum number of rooms, and initially we can set it to 1 and add the first interval to our min heap. It's going to be min heap dot add intervals 0. So to this meeting we have assigned this room, so that is why minimum number of rooms is currently 1. So now we are going to iterate over the remaining intervals. So we can create for int I equal to 1 and I less than intervals dot length I plus plus. And as discussed from algorithm walkthrough, now we have to compare the current interval with the minimum interval in our min heap. So for that I can create two variables. So this is going to be min interval, and this is simply going to be min heap dot peak, and our current interval, this is going to be simply intervals I. And now I can check if there is an overlap or not. So if min interval n time is greater than current interval start time, then this means there is an overlap of these two meetings and we have to increase the number of rooms. So I can do min rooms plus plus, and then we have to also add the current interval to our min heap. So it's going to be min heap dot add current interval, and for our else block we can simply do a poll from our min heap and also add the current interval to our min heap. And at the end we can either return min rooms or we can also return min heap dot size. So both of them are going to give us the minimum number of rooms. And for refactoring purposes we can bring this out of if else blocks because it's the same there, so I can just have it here. And also one optimization we can use, that instead of storing integer array in our min heap, we can simply store the n times in min heap, because we are not really using the index 0 value in this for loop. We are only checking the end time, so we don't need to store the start time in our min heap. We can simply store end times. So that is one optimization you can use. So now we have implemented both of our functions. So now let's try to run our test cases. So if I go to our main function and try to run it, so let's see our output. So in our output we can see that all the test cases passed. So this was the code implementation of both the problems, and I hope both of them made sense, and the algorithm walkthrough also made sense earlier. If you have any doubts, let me know in the comments. Thank you so much for watching, and I'll see you in the next video.